All right, let's just dive right in. We are absolutely swimming in data, right? But what about the stuff that doesn't fit? The glitches, the outliers, the genuinely weird data points. Today, we're going on a hunt for these anomalies, and you're about to see why finding them is one of the most important jobs in our digital world. Think about this. Right this very second, there's an invisible guardian working overtime to protect you. No, it's not a person. It's not some kind of physical shield. It's an algorithm, a silent sentinel that is constantly, relentlessly sifting through an ocean of noise just to find a single threat. And the threats it's fighting, they are very, very real. We're talking about stopping a fraudulent charge on your credit card before you even know it happened. We're talking about detecting hackers trying to break into a secure network. In hospitals, it's helping doctors spot malignant tumors in medical scans. It's even looking out for faults on spacecraft flying miles above us and flagging illegal insider trading on the stock market. This Guardian, it's everywhere. So what is this Guardian? Well, it's a technology called Anomaly Detection. And its entire job, its whole reason for being, is to find those critical, sometimes life-saving signals that are hidden in a ridiculously noisy world. In this explainer, we're going to pull back the curtain and see exactly how it works. So, what does it actually mean for data to be weird or, anomalous? Well, it turns out it's not quite as simple as just being different. In fact, data scientists have found it's really helpful to break weird down into 3 distinct types. The official definition sounds pretty straightforward, right? An anomaly is just a pattern that doesn't conform to what we expect as normal. But, and this is a big but, what that really looks like in practice? Well, that's where things get fascinatingly complex. Okay, so the first and simplest type is called a point anomaly. Let's go back to your credit card. Imagine you normally spend about 50, maybe 60 bucks a day. Then all of a sudden, bam, a single transaction for $5,000. That one data point all by itself sticks out like a sore thumb. It's a massive deviation, an obvious red flag. Next up, things get a little more subtle. We've got contextual anomalies. Now with these, a single data point isn't necessarily weird on its own. The weirdness comes from when or where it happens. For these anomalies, context is absolutely everything. And this slide is the perfect way to understand it. Look at the graph. A temperature of, say, 35 degrees Fahrenheit in the dead of winter at time T1. Totally normal. No one bats an eye. But that exact same temperature in the middle of a summer heat wave at time T2, whoa, now that's a huge anomaly. The data point itself didn't change, but the context flipped its meaning completely. And finally, we have collective anomalies. This is where it gets really clever. This is when individual pieces of data look totally fine on their own, but a specific sequence or combination of them is super suspicious. Think about cybersecurity, for example. One command sent to a server, probably harmless. A second command, also probably harmless. But when you see a very specific, unusual sequence of those harmless commands happen one after the other, well, that group of actions suddenly looks a lot like a potential attack. Okay, so now we know what we're looking for. The question is, how do we actually find these things? Well, let's open up the Anomaly Hunters Toolkit and check out the 3 core strategies they use to track down these outliers. Now, before we dive into the strategies, you gotta know the 2 main ways a hunt can start. Sometimes you're working unsupervised. That means you've just got this big, messy bag of data, and you have to find the weird stuff without any clues. Other times, it's semi-supervised, which is way nicer. That's when you have a clean, trusted set of what normal data looks like, which makes spotting the intruders a whole lot easier. This picture here just says it all, doesn't it? You can see how most of the data points, like the ones in that cluster C2, are all bunched up together. That's our normal. But then you've got these 2 loners, P1 and P2, way out there by themselves. Finding those outliers, the ones that are far, far away from the crowd, that's the fundamental goal. So we can pretty much boil down these complex hunting strategies into 3 core ideas. First, you can know what's normal. This is where you build a super detailed model of perfect behavior, like the exact right vibrations of a jet engine, and you flag anything that strays from that. The second is to spot the loner. This is more about geometry, just finding the data points that are mathematically far away from their neighbors, like that huge credit card purchase. And third, you can find the odd group out. This is about clustering data and realizing that those tiny, isolated little groups, well, they might just be a sign of coordinated trouble. But hunting for these signals is, well,
It's not easy. Not by a long shot. In fact, it's a constant, evolving cat and mouse game, especially when you're up against intelligent adversaries who are actively trying to hide their tracks.
And this is where that cat and mouse game gets so real. This quote from the source material just hits the nail on the head. Fraudsters, hackers, they know they're being watched, so they are actively trying to adapt, to disguise their weird behavior to look perfectly normal. It makes the job of any detection system incredibly difficult. And on top of that, the very definition of normal is like a moving target. The line between normal and weird is almost never a sharp boundary. It's super blurry. And what we consider normal today might be totally different tomorrow because systems and people evolve. Plus, what counts as an anomaly in medicine is worlds apart from an anomaly in finance. So you're constantly fighting this uphill battle against a massive, ever-changing sea of data, where the bad guys are trying their best to look just like everyone else. So given all these challenges, right, this constant, difficult game against evolving threats and shifting data, why do we even play it? Why does finding the unexpected matter so much? Because at the end of the day, this isn't just some abstract problem for data scientists. Anomaly detection is a foundational technology that is quietly working all around us every single day, protecting everything from our bank accounts to our actual physical health. It really is that silent guardian we all rely on. And while all the applications feel incredibly modern, the core idea has a really long history. This all started way back in the 19th century, with statisticians who were just puzzling over what they called discordant observations. Then, the need just exploded in the 80s with the birth of computer security. And today? Well, today, it's an absolutely crucial tool for navigating the insane complexity of big data, machine learning, and AI. And all this leaves us with one last big thought. We've gotten really good at finding the anomalies we already know how to look for. But as our world gets infinitely more complex and data-driven, the real challenge is going to be this. How do we build systems that can find the truly novel threats, the anomalies we haven't even imagined yet?